Here is a 3D model of an MEG refrigeration plant. The monoethylene glycol refrigeration process has been around for many years and was invented by Lawrence Reed. The famous Lawrence Reed Gas Conditioning Conference presented by the University of Oklahoma is named after him. First, the inlet gas passes through an inlet separator, which removes solid and liquid contaminants from the gas. From there, the gas is chilled through a series of gas-gas exchangers. In the gas-gas exchanger, warm feed gas is cooled down through the exchanger tubes while cold gas from the low-temperature separator, or LTS, warms up in the shell side to meet sales gas specification. Depending on the size of the plant and the amount of gas being processed, there might be one or more trains of gas-gas and/or gas-liquid exchangers. As the gas cools down, water holding capacity of the gas decreases and excess water drops out of the gas in the form of condensates on the inner surface of the exchanger tubes. As previously discussed in the section on hydrate formation, the environment in a gas-gas exchanger is favorable for formation and growth of a gas hydrate. The host molecule, mostly methane, is abundant in the processed gas. As the gas moves through the exchanger, the temperature is dropping, operating pressure is moderately high, and liquid water is condensing out of the gas, all favorable conditions for hydrate formation. If hydrates are formed, they can block the tubes and stop the gas flow. That is why MEG, a chemical inhibitor, is injected into the exchanger and functions as an antifreeze. Although MEG has high affinity for absorbing water, it only does so when highly pure and its concentration is higher than 90 to 92 weight%. While in a refrigeration unit, MEG's concentration is typically between 70 to 80 weight% in the lean solution and between 55 to 60 weight% in the rich, so the water is not absorbed. After passing through the exchangers, the gas is further cooled in the chiller. An exchanger involving a propane cooling loop, the processed gas enters the tube side, and propane is on the shell side. Theoretically, the temperature of the gas exiting the chiller is equal to its water and hydrocarbon dew point. Downstream from the propane chiller is the low-temperature separator, or LTS, the vessel where the glycol water phase is separated from the hydrocarbon phase. There is a boot below the LTS, which typically contains a heating coil to help with the separation of the natural gas liquids and the glycol solution. The warmer the temperature, the easier the separation. The boot allows for higher separation velocity between the hydrocarbon phase and the glycol water phase and acts as a collection point for the glycol solution.